stuff, right? If you make a power bar out of this stuff, you can fit like 1,000 of them in your pocket. No, I'm just kidding. I don't know. Right? Okay. It eventually runs out of carbon fuel. It gets dimmer and dimmer until it becomes a black dwarf. Now watch this effect. Watch this. Are you ready for this? I won PowerPoint of the year in 2001 with this effect. Did you see that? It like just fades out and becomes a black dwarf. Look out for those black dwarfs. They're the meanest ones. Let's see that again. Wait, hold on, we got to see it. You haven't seen it yet. Okay, you haven't. Wait till you see this next effect. Okay. Now for something completely different. Want to hear a scary story? Now we're getting into the crazy stuff, right? It could be supernovas, black holes, right? We are on a special schedule. This joke is that back in the day, right, we had a coded phrase for like armed intruder in the school, right? And it was, we are on a static schedule. Static schedule was lock the doors, you know, there's just somebody with a gun. I don't know why we needed to like have a code, right? You know, don't want people to be worried. We're just locking the doors and lying on the floor, right? Now the coded phrase is, look out for the guy with the gun, right? Yeah? Yeah, yeah, right. Now the coded phrase is right. You know, but then it was we are on a static schedule, and then here was the scary thing was that every now and then people would forget what the coded phrase was. So every time there was like an assembly schedule, like we are on an extended assembly schedule, people would be like, oh crap. Oh wait, no, that's the good one. No, is it? You know, what is it? I don't know what it is, right? You know, okay. Okay, Life After the Main Sequence, starring Marcella Supernova, Joe Neutron Star, Bob Quasar, Mary Pulsar. Afraid of black hole. Are you afraid of the black hole? Music, okay, that's cute, right? Okay, so now, if the mass is greater than 1.4 times the mass of the sun, this is called the Chandrasekhar limit. Let's all say that. Chandrasekhar, 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 Chandrasekhar. So when your parents ask you, you can yell that at somebody in traffic. No, don't, right? Okay. If your parents, if your parents ask you what you studied in physics, just say, well, we studied the evolutionary trajectories of super and sub Chandrasekhar stars, right? You know, super and sub Chandrasekhar. If it is sub Chandrasekhar, right, it just ends there, right? But if it's greater than the Chandrasekhar limit, right, it don't care about no Pauli exclusion principle. It don't care about that. There's no Pauli exclusion principle going to keep me from collapsing, right? It's going to collapse, right? So we are now the size of a planet. White dwarfs are the size of Earth. They're the size of, not like Jupiter, maybe they're Jupiter size, but they're just the size of planets. Planets are pretty small, okay? Neutron stars are the size of Portland. Now imagine Earth collapsing to something the size of Portland. Portland's big, but Portland's not that big, yes? Imagine something that's already really dense. It's already very, very dense. Okay, much more dense than Earth matter, right? It's like hundreds of thousands of times more dense. I don't even know, right? Not neutron star stuff yet, right? And it collapses from this size, already being dense, to the size of, well, yeah, there's nothing on this thing that you can see that's as small as Portland. Okay, you can barely see Portland at this scale, right? So it just collapses like that. Imagine that. Imagine the fury of that collapse. Are you imagining it? Okay, now you're going to feel the fury of that collapse, right? It releases an incredible amount of energy. For a few days, I don't know, less than a week, less than 2 weeks or something, it becomes brighter than an entire galaxy. If you see a galaxy that is having a supernova, one of its 100 billion stars, if one of those 100 billion stars undergoes a supernova, the brightness of that galaxy will double. You might not be able to see that star in that galaxy. It's very unlikely that you could even see, only nearby galaxies can we see the individual stars in there. But the galaxy itself gets twice as bright. Isn't that crazy? Yes? In fact, there's some, supernovas that are visible from Earth are part of the historical record. And it's one of the things that they can do, like to look at Mayan records and synchronize those with European records, is that we all saw the same supernova. Yeah? Isn't that kind of cool? It's like tree ring data, right? It's very hard to do New World and Old World, like synchronize the dates. Well, this is one of the ways we can do it. In fact, there's somebody who does this presentation where like the star of Jesus, right, they think that was maybe a supernova that happened at that time, right? And it would appear to be over there, and it would look like a new star, but it's actually in a distant galaxy, right? Okay, so watch this. Are you ready for this? We've described supernovas, we've talked about it, but now you're going to experience it. Wow! I don't know, do you want to see it again? Whoa! Wow! Whoa! Again, PowerPoint of the year, 2001. Okay, so the terrific energy released by the collapse of a star creates, this is how elements bigger than iron are made. Okay? Maybe a supergiant star could like store some energy and make something just a little bit bigger than iron, but uranium, plutonium, all of these things, okay, are made by supernovas. So the fact that we have those things in our Earth's crust, the fact that we have uranium in our Earth's core that is nuclearly decaying and keeping the Earth molten after 4.5 billion years, the reason for that is that our solar system was made from the remnants of a supergiant star explosion that happened before it was even born. Isn't that wild? So when you look at Mount Hood tonight, as the setting sun makes it glow pink in the perfectly clear day that we're going to have, right? Okay? Someday this summer, right, when you see, like in July, the end of July, right, when you finally see Mount Hood for the first time, okay, you know that Mount Hood is caused by the powerful tectonic forces. The Pacific plate is subducting under the North American plate. When it gets down hot enough to melt, all the lightweight stuff that's on the top of the Pacific plate is going to come bubbling up to the surface when it melts, and that's Mount Hood, right? The reason that it's so hot is that the Earth's core has huge, all of the really heavy stuff like uranium, all those things are radioactive, and it's radioactively decaying. It's turning matter into energy at the core of the Earth, and that energy was stored in a supergiant collapse of a car, right? So this basically, electrons get stuffed into protons. If you add an electron to a proton, it's like reverse beta decay, and it becomes neutrons. Yes? Doesn't that make sense? It's electrically neutral. A negative plus a plus is a zero, right? So this is why they call them neutron stars, because that's most of the matter has been turned into neutrons. Dogs become cats. Okay? Republicans support campaign finance reform only in these circumstances, right? And Democrats vote for tax cuts. Okay? There he is. It's a Tuesday. All right, that's all right. Okay? So all these incredible things that don't ordinarily happen in this situation, right? Okay? In 1987, a supernova occurred in the Large Magellanic Cloud. This is only 170,000 light years from Earth, so this is got to be a Milky Way object. No, wait, no, this is not. Of course not. Right? The Large Magellanic Cloud is that tiny galaxy, mini galaxy, elliptical that, right? We could see this with the naked eye, assuming that your eye is naked in Australia. It was a northern hemisphere thing, right? We can't see the large and small Magellanic Cloud, right? Here's a picture of it. Here's a picture of 1987. So 1987 is when we think, when we say it happened, of course it was 170,000 years ago, but you know, we don't have the date for that so much, right? Okay. Here are those rings. Now here is, in 1994, they took a picture of these rings, and this thing was not developed. In 1987, this ring had expanded beyond a little knot of material there. So we know these rings are moving out and that they're expanding, right? We don't know exactly what causes them, but they're cool, aren't they cool?
So where does all the stuff that the supernova ejects go? Does it just make up?
It's just going off into space. Eventually it'll become part of that crap you see in those other slides, right? All that dusty sort of looking stuff. Now, here are these things. Notice that there's this, what you just saw were slides of this big ring, right? Notice these other two rings. Why did it make those? I don't think we know. We don't really know. Isn't that cool? Okay. Here is galaxy M51. I think this is this the Whirlpool galaxy? I think it is. This is one of the things, if you get a telescope, a decent telescope, you can find this thing in the sky. And I'll tell you that story next time.